Hello everyone and welcome back to our channel. In the last video we learned about the insertion in a linked list. We talked about all the three types, that is insertion at the beginning, insertion in the middle and insertion at the end. So if there's an insertion, there's also going to be deletion. So in this video we are going to learn about all the three kinds of deletion, right? So let's start with the deletion from beginning. So let me create a sample linked list. We have a linked list that contains as of now 3 nodes, 1 2 3 3 is pointing to null, and yeah, start is currently pointing to 1. So when we say delete from beginning, we sort of mean that 1 should be deleted from this linked list, right? So how do we do that? It is really simple, because this is sort of like a one-liner. What you simply need to do is you just need to make your start point to whatever your current start's next was pointing to. So current start is 1, right, and its next is pointing to 2. So you just make your start pointing to 2, right? This way your linked list becomes start 2 3, sort of like this. You have your 2, you have your 3, start is pointing this, your 1 is sort of deleted, even though you know your 1 is still pointing to 2. Yeah, as of now it is pointing to 2, but that is none of our concern. 1 has become like a dangling pointer, but we're not discussing that as of now. But your linked list is simply basically 2 to 3, because your traversal starts from start only, right? So you have 2 3, and this is an example of deletion from beginning, right? Now let's talk about deletion from end. So let's take the previous linked list as an example for this also. We have 1 2 and 3. In this case we want to delete 3, right? So how are we going to do that? Again, let's just think like, I want to delete my 3. What should I do? The only thing that you are supposed to do as of now is currently the only way to reach 3 is via 2. So you just need to make your 2 stop pointing to 3, right? So you just need to reach till the second last node, that is, in this case, that is 2, right? Once you reach 2, you say that okay, the next of 2 should no more point to 3, rather it should point to null, right? This way your linked list now becomes 1 points to 2 and 2 points to 3. Now you have completely lost your reachability to 3, and this becomes your current linked list. So what are we going to do this step? You reach to the second last node, right? Not the last, but the second last node, and then you make it point to null. It doesn't matter what address it was carrying before, because we are supposed to delete that node. So you just make it point to null, and yeah, that is done. This is deletion from end. Now we are going to talk about deletion from middle. Again, let me create my sample linked list. This time let me put an extra node in this. We have 1 2 3 and 4. Perfect. So in this case what I'm going to do is I'm going to delete 3. So how do we do that? Let me just get my arrows correctly. 1 2 3 4. Perfect. So like what I'm going to do is, this is the node. Let me just mark it with red. This is my node that I want to delete, the 3 1. Okay, so in order to delete 3, we need to understand one thing, like what exactly is making 3 a part of this linked list. It is actually 2. Just because 2 has the address of 3 in its next node, 3 has become a part of this linked list. If, let's say, we make 2 start pointing to 4, 3 will be lost. Your linked list will become 1 2. 2 has the address of 4, and 4 is pointing to null. So in a way 3 has been deleted, but definitely, I mean, if you look at the broader picture, 3 is actually there dangling, right? It is still pointing to 4, but that is of no concern to us, because we don't know the location of 3. We have no way to reach 3, right? So after let's say if I make my 2 pointing to the next of my 2 start containing the address of 4, all of my tensions are gone. My node 3 has been deleted successfully. So how do we do that? Very simple. What you're supposed to do is you just say that let's say 2 dot, this field is called next, right? So 2 dot next should become equal to what? It should become equal to 2 dot next dot next. What is 2 dot next in this stage, right? In this stage period when we have 4 node, 2 dot next is this, and 2 dot next is this. So you say, okay, in this field we are supposed to store 2 dot next. That means we are supposed to store 4. So your 2 will start pointing to 4, 3 will become a dangling pointer, and you have successfully deleted 3 from your linked list. So yeah, that was all. We have covered delete from beginning, delete from end, and delete from middle, right? So now let's try to code those all out, and we'll see them in the live coding. Yeah. All right, starting from delete from beginning function, it needs a parameter called as self. Self is actually equivalent to this in C++. Okay, and what are we supposed to do? We are supposed to make the head point to the next direction, right? To the next node. So self dot start dot next. Yeah, this is done. This is your delete from the beginning, and yeah, now let's move to the next function. We are going to write all the functions, and at the end we are going to run them together. All right, so delete from end. Again, on we only need self parameter, right? So how are we going to delete from end? Let's create a temporary pointer that is pointing to where start is pointing, and then this temp will be pointing to the second last node, right? So how do we do that? Say, okay, while temp dot next exists, you traverse till there. This is the traversal logic, temp dot next. Yeah, we're done. And once you reach the second last node, you just make your next equal to none, right? So once you reach the second last node, you just say, okay, now instead of pointing to the last node, you just point to none. And yeah, that is done. Delete from end. Really simple, right? So after that we have delete from middle. This is going to be a little bit longer. Here we need two parameters, self and position. Position basically indicates which node you want to delete, right? Okay, so again, we need a temporary pointer. We need a self dot start. Now we need to validate a few things, right? If the position is 0 would mean that if you want to delete the first node, if that is the case, then you just are supposed to do this. Self dot start will be equal to temp dot next. This is sort of the same function, right? Delete from beginning, and then my bad, and then you return, right? uh, when you do delete from beginning, you might encounter a lot of edge cases, so you just need to handle that, right? Apart from that, now what we need to do is we need to reach till just a node before the position indicated, right? So how do we do that? We run a for loop for I in range of position -1. This will lead us to basically to the point. I mean, let's say if I want to delete the third node, this will lead us to the second node, right? Because at the second node we have to do the main changes. So for I in range of position -1, what we are supposed to do, make our temp point to temp dot next. This way we'll move forward. Meanwhile, this can be also the case. Let's say you have only 4 nodes and you are given a position of, let's say, 10. So that can sort of give you an error. So if you want to handle that, you can just write this in between. If temp is none, you can just break it out, right? And yeah, you can also print a log statement that this is out of bound or something like that. Doesn't really matter right now. Also, you also need to check that the last node that you're at is also not none. So again, the same check. Yeah. Right, now comes the main piece. How are we going to, let's say we have reached the second last node, what we are supposed to do right now. So let's create let's create some sort of pointer called as next, and next will be pointing to temp dot next. So see, if we have 2, 3 and 4, right, and we are at the 2 currently, so next will be start pointing to 4, right? Next has sort of become a pointer for 4. Please try to imagine, let's say you have this pointers 2, 3 and 4, right? You are trying to delete 3 here. So currently you are at 2, your next is now pointing at 4 due to temp.next.next. Okay, and now what you'll do is you just make your temp dot next equals to, my bad, temp dot next equals to none, right? And then you make your temp dot next equals to Next, this way what we have done here is basically you have made your 2 instead of pointing to 3, you have made it point to 4. So yep, that is all for delete from middle. Now let's try to see the implementation. Okay, so here let's say I've created a linked list of 5 elements, right? What is going to be printed? 1, 2, 3 and 4 and 5, right? Let's call all the functions. Let's call delete from beginning, and when we call display function after this, what should be, what should we get printed? It should be basically 2, 3, 4 and 5, right? And then you call delete. I'm not sure why it's not auto suggesting me. I have to write it all the way from end, and then you if okay, and then you call the display function, and what should be getting printed is 2, 3 and 4, right? 5 should be deleted when you call delete from end. So yeah, and now let's call ll dot delete from middle. Okay, uh, and yeah, it needs a parameter, right? It needs a position, so I will say 1. 1 would mean that I want to delete this is like 2 is 0, 3 is 1 and 4 is 2. So speaking of position wise, so 3 should be deleted, right? So after this, if I call lit dot display, I should be getting only 2 and 4, right? So let's run this and see if it is working as expected or not. Perfect. So here initially we had 1, 2, 3, 4, 5. Then we called delete from beginning and we got 2, 3, 4 and 5. Then we got delete from end and we got 2, 3, 4, right? 5 was deleted. And then we called delete from middle with a position of 1 and 3 was deleted and we got 2 and 4. So yep, all of our functions are working perfectly. Remember in delete, right, there can be a lot of edge cases, like what if there is no linked list, or what if the value is not there, or some case or another. So you can actually put a lot of validation before that, like validating if the start is pointing to null or not. I haven't really implemented that here because I wasn't really trying to show you all the edge cases. I was just trying to show you the main logic here. But if you want, you can definitely add a basic function here of checking, like if let's say self is self dot start is none, then return. I mean, you can actually add a lot of functions like this. So this will do a validation of deletion, because deletion is it can give you a null pointer, right? If let's say you're deleting something that doesn't even exist, so you need to have your cat statements there, right? So this was all for deletion of a linked list, and yep, thank you for watching.